In this question, they ask you to find the area under the triangle that was designed by connecting the lines through 3 points. So I have to find the area that I'm shading right now. So this area has to be found. But in order to find this area, I need to write the equation for each line. So if I take these 2 points and use the point slope form of the equation line, so I have y minus y sub 0 is equal to mx minus x sub 0, and I'm going to use one of the points. I can use like 1 and 6, so I will have y minus 6 is equal to x minus 1. And if I look at the slope of this graph of the line, so I have the rise is 4 and the run is 2. So the slope is negative 4 over 2 or negative 2. So the equation of this given line is y equals to negative 2x plus 8. For the next line, let's look at the other ones are actually easier. We can use not the point slope form, we can use the slope intercept form. Y is equal to mx plus b. So for the next 2 points, I'm going to choose these ones in green. If I write the equation for this line, I'm going to have y is equal to, and the slope is 6 over 1 or 6x, and the y-intercept is 0. For the next one, let's do it in blue. So it's the 0, 0 and 3, 2. The next equation would be y is equal to, the slope is, the rise is 2 over 3, so that's 2 over 3 x, and the x-intercept is 0. So we have these equations for each line. This one is 2/3 x, and the one that is, maybe I will erase this line so I can fit my equation. So this one is y is equal to 6x. And then the point was 1, 6. I still will need that. Now to find the integral, I'm gonna look at 2 different areas. The first one is gonna be until 0.16. So I'm gonna look at this one. And it may be great shaded in green, and then the second one is going to be shaded in blue, and then I'm going to add these 2 areas. So for the green part, I have the integral, and on x-axis we're going to go from 0 to 1, and the function that is on the top is 6x, and the function that is on the bottom is 2/3 x. dx. And then for the blue part, we have, so we're going to add the other integral, and that one is going to be between 1 and 3. The top function is negative 2x plus 8, and the bottom function is 2/3 x, and again dx. So if we collect like terms for the green function, for the green integral, we will have 16x over 3 dx, and if we collect like terms for the blue integral with the limits between 1 and 3, we will have negative 8x over 3 plus 8 dx. Taking the integral of each, we have 8 over 3 x squared, and then the integration between 0 and 1, and taking the integral of the second integral, so we will have negative 4/3 x squared, and then plus 4x with integration points between 1 and 3. If I plug in 1 for the green part of my expression, I will have 8 over 3, and if I plug in 0, I will have a 0. And then if I plug in a 3 instead of x for the blue part, I will have negative 4 times 3 plus 4 times 3, which is 12. So I'll have negative 12 and a positive 12. And then if we do the same for 1, so I have to subtract. And if we do the same for 1, I'll have negative 4/3 plus 4. Now, collecting like terms, we have 8 over 3 plus 0 plus 4 over 3 and plus 4. 8 over 3 plus 4 over 3 is 12 over 3, which is 4, plus 4 will give me 8. So the area shaded in our graph, the total area, is 8 units.